welcome back guys after a so long time. Actually I was busy in few of my tasks, so let's begin. uh, Today I will be discussing about two concepts. First one is unbiased estimator. So what is this, and I will show you one example. And the second concept is central limit theorem, right? So starting from the first concept, uh, unbiased estimator. So the estimation bias of an estimator y for an arbitrary parameter p is, so I am talking about bias, right? Is given by expectation of y minus p. So what I said, p is an arbitrary parameter, right? So if this is equals to 0, so if the estimator bias is 0, then we say that y is an unbiased estimator of p. So y is an unbiased estimator for p, right? uh, so you can notice that this will be the case if the average of many random values of yi, okay, so y1, y2 up to yn generated by repeated random experiments. So I'm doing many random experiments, and we are taking the average. So by average I mean expectation of y, okay. So if this converges to p, if we are doing many experiments, and if the average of such outcomes is approaching p, then it is unbiased estimator. Let me give you one example. So the example is whether error from a sample is an unbiased estimator for error for whole dataset, yes or no. So okay, and the thing that we know is that, uh, suppose it is a binomial distribution, meal distribution, okay. So let's check. So first of all we need to find the bias. So error of the sample minus error dh is equals to 0 or not, we need to check, right? So let's break this. What is uh, error of a sample given, suppose we have done one experiment, right? So the experiment is like head or tail. So we are tossing some coins, and we are asking how many tails are there. So suppose we have tossed n number of coins and we got r number of tails, right? So our error will be r by n. So our error for that, for this sample, is nothing but r by n, right? And what is error for this entire data set? It is R only, right? So yeah, and we also know for binomial distribution, estimation expected value of R is given by n times p, right? N times p you say, or n times of R. So finally, for expectation of R by n, it will be n by R into, sorry, R by n, R by n into n, right? So n get cancelled and the resultant value will be R. So finally our answer will be R minus R, that is 0, right? So it is a unbiased estimator. Let's move to second concept, that is central limit theorem. So it states that the probability distribution governing y bar n approaches a normal distribution as n tends to infinity, regardless of the distribution that governs the this random variable, right? So what is y bar n? It is nothing but 1 by n summation from I equals to 1 to n yi. What is yi? Yi is any random variable, right? And it should be independent identically distributed random variable, maybe like number of heads or number of tails while tossing n times. It can be also assumed to be y, okay, y1, y2. So what it actually is saying is that we have a lot of experiments, if we are if we have lot of samples, right? Not exactly sample, but if we are doing a lot of experiments and we are collecting the outputs, right? So if we sum all the experiments, then we will be getting a distribution which follows a normal distribution. So what we can say, suppose we have a set, right? Set of what? Set of independent identically distributed random variables. So it is y1, y2, y3 up to yn, okay, and it is governed by some probability distribution which we don't know. Suppose the distribution is PD, probability distribution. So this probability distribution will be having some mean, okay, and will be having some variance. So if we take the sample mean of all this random variable, right, for all I, yi, then as n tends to infinity, means if we have a lot of these random variables then the distribution, then this distribution will be tending towards normal distribution. So this will be mu by n. Okay, so this will be tending towards 0. I mean the mean of this random variable, the newly formed random variable, will be 0, and the distribution and the standard deviation will be 1. So yeah, this was all for today. Let's meet